Late April 1943, a sunlit ridge near Jebel Jaffa, Tunisia, echoed with the mechanical growl of retreating German armor under Allied pursuit. The American 2nd Armored Division advanced cautiously across the broken terrain, their Shermans maneuvering past burned-out half-tracks and smoldering Panzer wreckage. The North African campaign had turned decisively, and for the first time, American tank crews encountered the terrifying silhouette of the Tiger Wars. This machine, known to the Germans as Panzerkampfwagen 6 Tiger Ausf E, represented armored warfare's most formidable evolution of its time. Weighing 57 tons and fitted with an 88mm KWK-36 gun, it projected power far beyond anything previously faced. Its thick, interlocked armor plates, some exceeding 100 millimeters, rendered it virtually impervious to the Sherman's 75mm rounds at standard engagement ranges. As the dust settled, Lieutenant Walter Boland's platoon discovered one abandoned Tiger near a wadi, its crew hastily retreating northward. The immense vehicle, partially disabled yet intact, drew astonished eyes from every American tanker who approached its massive steel carcass. Mechanics examined the German engineering with disbelief, noting the precision-machined components and the complexity of its transmission systems. Inside, the cramped fighting compartment smelled of oil, metal, and singed rubber, with ammunition racks still half-loaded beside discarded helmets. The men circled it like archaeologists, uncovering a relic from another civilization, uncertain whether admiration or fear should dominate their reactions. Nearby, British liaison officers recognized the extraordinary intelligence value, urging immediate transport to a secure rear area testing facility for Allied examination. Within hours, recovery crews hauled the Tiger onto a flatbed transporter, the treads groaning beneath its oppressive weight. Every detail, from the overlapping road wheels to the precision-cut turret gears, spoke of an industrial philosophy obsessed with mechanical perfection. Yet the Allies would soon learn that such perfection carried crippling consequences, revealing vulnerabilities hidden beneath its terrifying reputation. As the captured tank rolled toward the docks near Bizerte, engineers speculated about fuel consumption, mobility, and maintenance demands under desert conditions. Few realized that the Tiger's logistical burden rivaled its combat strength, draining Germany's dwindling fuel reserves with alarming efficiency. The Americans noted its odometer reading, barely 120 miles since full refueling, an astonishing figure for such engineering power. To them, this single discovery symbolized the paradox of German design brilliance, unmatched firepower shackled by unsustainable mechanical excess. And in that moment, beneath the Tunisian sun, the Allies began to see the limits of Nazi technological supremacy revealed through steel. Early May 1943, at the Allied Ordnance Depot near Bizerte, Tunisia, the captured Tiger high rested beneath heavy tarpaulins, guarded by armed sentries. The machine's immense frame dwarfed nearby Shermans, its imposing presence drawing a steady stream of engineers, mechanics, and intelligence officers. This particular Tiger, bearing serial number 25012, had belonged to Schwer Panzerabteilung 501, one of Germany's most formidable heavy tank battalions under the Afrika Korps. Its capture provided the Allies with their first intact specimen of the feared weapon that had dominated European battlefields. Around it, technicians prepared for methodical examination, understanding that every bolt and bearing could unlock crucial insights into the German war machine. The dismantling began cautiously, with teams photographing each stage and cataloging components into wooden crates marked for later shipment to the United States. American ordnance specialists collaborated closely with British technical experts, translating factory inscriptions and recording measurements to the nearest millimeter. They found the Maybach HL230 P45 engine remarkably sophisticated, capable of producing 700 horsepower at maximum output. Yet its mechanical beauty concealed inherent weaknesses that explained the Tiger's frequent breakdowns during desert operations. Cracked final drives, worn clutches, and carbon-fouled filters revealed an engineering philosophy obsessed with power, but indifferent to endurance. As analysis deepened, the engineers uncovered a truth far removed from the Tiger's terrifying reputation among Allied tank crews. Field reports recovered from the driver's compartment described constant overheating and rapid fuel depletion, even under moderate travel conditions. The Tiger's average consumption exceeded 5 gallons per mile, an astonishing figure in a theater already crippled by Axis fuel shortages. American crews who had fought the vehicle in Tunisia began realizing that its greatest vulnerability was not its armor, but its appetite for gasoline. The massive fuel tanks, though armored, offered only limited operational range before refueling became an urgent necessity. By mid-May, the captured Tiger was fully stripped, its intricate gear assemblies and overlapping suspension links awaiting transport to Aberdeen proving ground for further analysis. What had once been Germany's armored symbol of invincibility now lay dissected upon wooden pallets beneath the North African sun. For Allied engineers, the discovery marked a turning point in understanding German industrial design, revealing a machine where tactical brilliance clashed fatally with logistical impracticality. The Tiger's legend endured, but its mechanical truth began to unravel under the scrutiny of methodical Allied science. Late May 1943, Aberdeen Proving Ground, Maryland, received the disassembled Tiger the Fern under strict security after weeks of transatlantic transport. Engineers assembled a dedicated team of ordnance officers, metallurgists, and mechanics to reconstruct the captured German tank piece by piece. The arrival sparked immediate excitement across Allied research circles, marking the first opportunity to study Germany's most formidable armored vehicle in controlled laboratory conditions. Every mechanic understood the importance of the moment, realizing that knowledge gained here could reshape future tank development across Allied nations. Reconstruction began within a hangar modified to accommodate the Tiger's massive frame, supported by hydraulic cranes and reinforced flooring. American technicians reassembled the chassis with precision, matching photographic documentation from Tunisia against their detailed mechanical diagrams. The Maybach engine, recovered in fair condition, was mounted for bench testing to verify its power output and efficiency under American-grade fuel. Observers watched as the motor roared to life, filling the hangar with dense exhaust and vibrations that shook nearby tool cabinets. The power impressed everyone present, yet its instability under sustained operation became immediately clear to every listening ear. Cooling tests followed, revealing one of the Tiger's most critical limitations under non-European conditions. Despite advanced radiator design, the engine's temperature spiked alarmingly after only brief high-load intervals. Mechanics noted severe coolant leakage caused by pressure fractures along welded joints, a recurring failure previously reported by German crews. Engineers concluded that while the tank's design excelled in short bursts of combat, it was entirely unsuited for prolonged mobility in harsh climates. Desert sand or mud would quickly compromise the exposed components, rendering maintenance nearly impossible under field conditions. Attention then turned to the Tiger's armor, a subject of deep fascination among Allied metallurgists. Samples extracted from the hull revealed homogeneous rolled steel with remarkable hardness, yet noticeable brittleness under extreme impact. When tested against American armor-piercing rounds, the upper glasses resisted penetration at moderate range, but showed internal cracking under repeated strikes. Analysts concluded that German metallurgy favored thickness over elasticity, sacrificing long-term resilience for immediate defensive strength. The discovery underscored that the Tiger's invulnerability was impressive, yet finite under sustained firepower concentration. Next, the 88mm KWK-36 cannon underwent detailed evaluation on Aberdeen's artillery range. Firing trials confirmed its extraordinary precision, penetrating Allied test targets at distances where Shermans could barely score a hit. However, the ammunition's complex construction demanded precise manufacturing tolerances difficult for Germany's strained wartime industry to maintain consistently. Allied experts admired its engineering brilliance, while recognizing the impossibility of mass-producing such weapons under constant resource shortages. By early June 1943, the testing phase confirmed what field crews in Tunisia had suspected but never fully understood. The Tiger I embodied the height of mechanical sophistication, yet carried within it fatal contradictions of over-engineering and excess. Each system performed magnificently in isolation, but collapsed when sustained across real operational conditions. For American analysts, the revelation marked a turning point in armored warfare philosophy, favoring reliability and range over intimidating complexity. Mid-June 1943, Aberdeen Proving Ground, Maryland, became the stage for the Tiger I's most revealing field demonstration under American supervision. The reconstructed tank, painted in faded desert yellow, stood ready beside rows of Shermans, Grants, and experimental prototypes awaiting comparative trials. Engineers, officers, and journalists gathered behind barricades as the Tiger's Maybach engine thundered to life, its deep mechanical growl resonating across the proving fields. The test's purpose was simple: to determine whether German engineering supremacy could truly dominate Allied practicality under identical terrain and fuel conditions. As the test commenced, the Tiger rolled forward across uneven ground, crushing wooden barriers effortlessly beneath its massive steel tracks. Observers watched in awe at its stability and recoil control as the 88mm cannon fired successive rounds with extraordinary precision. Shells shattered distant targets at over 2,000 yards, leaving no doubt about the weapon's unmatched accuracy and penetrating power. American gunnery experts admitted the gun's optics and ballistic performance surpassed anything in their arsenal, including the latest M1A1 tank guns under development. Yet even as admiration filled the crowd, the first warning signs of mechanical strain began to emerge. The Tiger's steering clutches overheated rapidly, producing a pungent odor of burning friction material that drifted across the testing range. Its transmission began slipping under the pressure of steep inclines, forcing engineers to halt the demonstration temporarily for cooling adjustments. Mechanics documented every malfunction carefully, realizing that such failures mirrored reports from captured German maintenance logs found in Tunisia. The sheer complexity of the interlocking road wheels and final drive assemblies demanded maintenance procedures impractical for field conditions. For every hour of operation, the Tiger required nearly 10 hours of service, a logistical impossibility for sustained campaigns. Further tests examined mobility and fuel endurance, pitting the Tiger against the lighter Sherman M4 across identical routes and distances. Where the Sherman completed laps efficiently, the Tiger consumed enormous quantities of gasoline, its tanks emptying before the course concluded. Engineers recorded a total range of 120 miles per full tank, confirming earlier field estimates gathered from Tunisian operations. The revelation stunned even experienced ordnance officers who realized that Germany's most formidable tank was effectively immobilized by its own appetite. Its immense armor demanded such power that efficiency became an afterthought, rendering it tactically magnificent but strategically unsustainable. The demonstration ended under mixed applause and quiet realization among Allied observers standing beneath the humid Maryland sky. The Tiger. I had proven its lethality beyond argument, yet its weaknesses stood equally exposed for the world to see. Germany's engineering triumph, once considered invincible, now appeared as an extravagant monument to industrial obsession rather than enduring military practicality. In that moment, beneath the clatter of cooling metal and distant applause, the Allies understood precisely why superior design alone could not secure victory. Late June 1943, the evaluation teams at Aberdeen Proving Ground shifted from demonstration to detailed analysis, translating raw performance data into strategic understanding. Every subsystem of the Tiger I was examined in isolation, revealing patterns that illuminated both its brilliance and its fragility. The 88mm KWK-36 gun, though masterfully engineered, imposed enormous weight demands that reverberated through the entire mechanical structure. Its reinforced turret ring and hydraulic traverse system consumed significant engine power, forcing constant strain on transmission gears and cooling components. Engineers concluded that the weapon's power was both its triumph and its undoing, demanding an energy balance the vehicle's core systems could not sustain. Attention turned next to the suspension and track assembly, a hallmark of German mechanical sophistication that perplexed Allied observers. The Tiger's overlapping road wheels provided exceptional stability across uneven terrain, distributing its mass efficiently and maintaining smooth target alignment during fire. Yet this design required hundreds of grease points, specialized wrenches, and constant cleaning to prevent jamming from mud or sand accumulation. During North African and Eastern Front conditions, such delicacy proved disastrous, immobilizing tanks for days after minor environmental interference. American mechanics estimated that the maintenance workload exceeded feasible combat standards by a margin impossible for wartime field units to support. Fuel logistics reports further exposed the Tiger EES' impractical nature when viewed through the lens of operational sustainability. With fuel consumption exceeding 5 gallons per mile, supply convoys could barely sustain a handful of tanks over long distances. Each battalion required staggering quantities of gasoline, effectively tethering these armored giants to vulnerable depots and restricted front-line mobility. Allied analysts emphasized that while the Tiger could dominate isolated skirmishes, its endurance collapsed within extended campaigns requiring rapid maneuver and deep penetration. The vehicle AS limitations confirmed that Germany, ES armored doctrine, prioritized battlefield intimidation rather than continuous operational reach. Meanwhile, ordnance designers in Detroit and London quietly applied the findings toward future Allied tank development programs. Engineers studying the captured Tiger emphasized reliability, standardized parts, and logistical efficiency over raw armor or gun size. These lessons influenced the evolution of the M26 Pershing and British Centurion, vehicles designed to blend power with practicality. By transforming captured enemy technology into learning material, the Allies achieved an intellectual victory that matched any battlefield success. The Tiger's weaknesses became the blueprint for progress, teaching future armies that war favored endurance, not extravagance. Early July 1943, Washington and London received comprehensive technical reports from Aberdeen, detailing every discovery surrounding the captured Tiger I's performance. The findings were distributed across Allied command centers, influencing armored warfare strategies and procurement policies for the remainder of the conflict. Senior planners recognized that Germany's reliance on complex heavy tanks created vulnerabilities within its own logistical network, straining both manpower and fuel reserves. Instead of matching that philosophy, the Allies refined their approach, emphasizing mass production, mobility, and sustainable maintenance over mechanical perfection. This strategic divergence marked one of the most decisive intellectual shifts in the war's industrial narrative. At the War Department's Armored Board, officers analyzed the Tiger's endurance data with mounting interest, comparing its operational efficiency to Allied vehicles deployed in Sicily and Italy. The M4 Sherman, though technically inferior in armor and armament, proved capable of long-distance operations with minimal mechanical failures. Reports demonstrated that 5 Shermans could operate continuously for the fuel required to move a single Tiger the same distance. This efficiency not only allowed greater battlefield flexibility, but ensured that Allied logistics maintained steady momentum across multiple theaters simultaneously. The Tiger, by contrast, remained trapped within narrow corridors of tactical engagement, unable to exploit its own power across dynamic front lines. The realization carried significant implications for future combat doctrine. Allied strategists began developing tactics focused on attrition, flanking, and coordinated artillery rather than direct tank duels against German heavy armor. The air superiority achieved through Allied fighter bombers further neutralized the Tiger's effectiveness, as supply convoys supporting these massive machines became vulnerable to strafing. Intelligence divisions also exploited the Tiger's logistical dependence, targeting fuel depots and repair units rather than the tanks themselves. Such indirect strategies reduced German armored strength faster than conventional engagements ever could, reshaping battlefield dynamics entirely. As news of the captured Tiger's analysis spread among Allied divisions, morale quietly strengthened within field ranks. Tank crews understood that their seemingly inferior machines possessed the advantages of simplicity, reliability, and range, qualities Germany had sacrificed for intimidation and prestige. This understanding reframed the psychological dimension of armored warfare, transforming fear into measured confidence across Allied forces. In workshops and planning rooms alike, the Tiger ceased being a symbol of terror and became instead a lesson in flawed ambition. From that insight, the Allies derived not only tactical superiority, but the philosophical foundation of industrial victory. Mid-July 1943, the Tiger I sat immobile within an Aberdeen storage hangar, its once feared presence now reduced to a silent, mechanical relic. For the American and British personnel who had studied it, the machine represented both fascination and disbelief, an artifact that embodied the psychological warfare waged through industrial might. Soldiers who had faced Tigers in Tunisia recalled the paralyzing dread of hearing its distinctive engine growl echoing through distant valleys. Crews described the way its 88mm cannon shattered confidence as much as steel, forcing retreat before engagement even began. The tank's legend preceded its arrival on every battlefield, its silhouette alone enough to command respect and fear among inexperienced units. At Aberdeen, that aura slowly dissolved as the engineers stripped away myth and exposed the flawed mechanics behind its power. Sergeant Robert Mackenzie, a maintenance specialist, noted in his report that the Tiger is a fine machine built for the wrong kind of war. His words captured a growing sentiment among Allied troops who began viewing German engineering not as invincible, but as impractical brilliance divorced from battlefield reality. Visiting officers watched as grease-stained technicians climbed across the dismantled hull, their expressions reflecting both admiration and relief. For them, the discovery that such terrifying strength could collapse under its own mechanical weight was profoundly humanizing. It reminded them that the enemy, however advanced, was constrained by the same material limits and exhaustion that plagued all armies. Letters sent home by American tank crews began mentioning the captured Tiger as proof that fear could be conquered through understanding. Soldiers who once whispered about indestructible German armor now joked about the Tiger's thirst for fuel and tendency to break final drives under stress. This psychological reversal, though subtle, spread rapidly across armored units preparing for operations in Italy and France. Commanders noticed improved morale and renewed faith in Allied equipment, as men realized that their simpler machines often outlasted Germany's celebrated behemoths. Knowledge became a weapon more potent than armor, dispelling myths that had once magnified German strength far beyond its actual measure. By the end of that summer, the Tiger's transformation from terrifying adversary to technical curiosity symbolized a deeper human truth about warfare. Behind every machine existed the limitations of its creators, their pride, ambition, and blindness to practicality. The Allied soldiers, through understanding their enemy's masterpiece, had reclaimed not only tactical confidence, but psychological equilibrium in the brutal machinery of modern war. Late July 1943, the Tiger I's disassembly concluded at Aberdeen, marking the completion of one of the most comprehensive technical evaluations of the war. The vehicle's components were meticulously documented, photographed, and stored for reference within the Ordnance Museum archives. Engineers compiled thousands of data sheets detailing everything from armor metallurgy to suspension tolerances, transforming battlefield salvage into enduring scientific resource. The analysis offered conclusive proof that German engineering, while revolutionary in design, was fundamentally incompatible with the logistical demands of sustained global warfare. It was the triumph of efficiency over extravagance, and the Allied leadership understood that victory depended not on singular power, but on industrial adaptability. In Europe, these conclusions found immediate expression through tactical doctrine and equipment refinement. The American M4 Sherman received up-armored variants, enhanced suspensions, and improved 90mm guns informed directly by studies of the Tiger's combat advantages. British engineers incorporated similar lessons into the forthcoming Centurion project, which emphasized durability and maintainability above mechanical complexity. Even Soviet analysts, informed through Allied cooperation, recognized parallels between the Tiger's weaknesses and earlier Soviet experiences with over-engineered prototypes. Thus, the captured tank S dissection contributed to a global evolution in armored design philosophy, an intellectual front as vital as any physical battlefield. Meanwhile, within German command circles, reports of the Allies' access to captured Tigers generated quiet alarm. High-ranking officers feared that technological secrecy had been irrevocably compromised, exposing critical design principles to enemy replication. Yet even as they pursued further innovations, such as the Tiger II and Panther variants, fuel shortages and production bottlenecks undermined every advancement. The Tiger's legacy inside Germany became increasingly symbolic, an emblem of prestige rather than practical warfare capability. What had once represented dominance now embodied desperation. As each new model demanded resources the Reich could no longer supply. The tank's might had become its own undoing, a monument to industrial overreach in an age demanding restraint. Back in Maryland, the Tiger's hull rested beneath museum lighting, surrounded by the curious and the contemplative. Technicians occasionally revisited it for comparative studies, marveling at the craftsmanship yet recognizing its tragic inefficiency. To them, it was no longer an enemy, but an artifact of human ingenuity shaped by flawed ambition. The Tiger had fought ferociously, yet ultimately succumbed to a simpler truth. War rewards endurance, not indulgence. Its story closed not in triumph or destruction, but in quiet understanding of mechanical mortality. August 1944, the findings from Aberdeen's Tiger I evaluation were circulated among Allied design bureaus, establishing a formal framework for post-war armored research. The comprehensive reports documented structural vulnerabilities, excessive fuel consumption, and overstrained transmission assemblies that severely restricted battlefield endurance. American ordnance officers noted that despite its imposing presence, the Tiger's operational radius rarely exceeded 120 miles under ideal conditions. This limitation rendered the tank strategically immobile across fluid theaters, particularly compared to the logistical agility of Allied mechanized divisions. Thus, analysts concluded that the Tiger's brilliance in isolation could not compensate for systemic inefficiency, confirming that true power stemmed from mass production, maintenance simplicity, and fuel economy. At the British School of Tank Technology in Chertsey, engineers pored over detailed blueprints derived from captured German schematics. Their conclusions reinforced Aberdeen's assessments, highlighting the excessive precision tolerances that hampered field repairs and replacement part standardization. It became evident that German tank philosophy valued craftsmanship above practicality, resulting in vehicles that demanded factory-level maintenance, far from accessible supply chains. This realization influenced the conceptual design of post-war British armor, including early prototypes of the Centurion, which prioritized serviceability and component interchangeability. Allied strategists interpreted these lessons as confirmation that industrial pragmatism, rather than mechanical perfection, defined the battlefield of the modern age. In Germany, captured technical intelligence reached the Reich's upper command through intercepted communications and frontline reports. The Wehrmacht's tank inspectorate, alarmed by the Allies' analytical success, sought to conceal data regarding late-model prototypes. However, resource shortages, bombed factories, and fractured logistics networks made secrecy increasingly impossible. German tank crews began to experience operational fatigue as spare parts vanished, forcing cannibalization of damaged vehicles just to keep platoons functional. The Tiger's mechanical superiority had become an unbearable logistical burden, eroding morale and reducing entire armored units to immobile fortresses. As the Reich collapsed, engineers realized their most advanced weapon had already been defeated by arithmetic, fuel, and time. By 1945, when Allied forces advanced into the shattered industrial regions of Germany, they encountered rows of abandoned Tiger hulls stripped of engines and tracks. These silent relics illustrated the ultimate paradox of Nazi engineering. Weapons too advanced for the world sustaining them. Historians would later interpret the Tiger S saga as both a triumph of design and a failure of strategy, a machine that symbolized the peril of technological arrogance. Its legacy, preserved in steel and memory, warned future generations that brilliance without balance always breeds downfall. Early May 1945, as victory parades filled the streets of Allied capitals, the Tiger I's story transitioned from battlefield legend to historical monument. Across museums, training centers, and archives, fragments of the captured tank now served as enduring educational relics. Engineers, soldiers, and historians examined its armor plates and transmission gears, not as instruments of fear, but as evidence of technological obsession. The lessons extracted from its dissection extended far beyond metallurgy and mechanics, shaping post-war doctrines that valued efficiency, reliability, and adaptability. It became a cautionary relic, reminding every future commander that machinery without sustainability is ultimately self-defeating. At Aberdeen Proving Ground, the Tiger remained preserved beneath quiet fluorescent light, its steel frame standing as a silent professor of wartime engineering. Visitors approached with a sense of reverence, acknowledging both its brilliance and its futility. American officers used the captured tank during instructional lectures, demonstrating that innovation, when detached from strategic pragmatism, becomes an artifact rather than an advantage. The tank's once revered aura of invincibility had dissolved into measured respect, a transformation from weapon to warning. Even decades later, its mere silhouette evoked a mixture of admiration and sorrow, bridging technical awe with moral reflection. Across Europe, scattered remains of destroyed Tigers continued to emerge from forests, fields, and riverbeds long after the war's conclusion. Each recovery reignited debate among historians and restoration experts regarding the paradox of German design philosophy. The tank had embodied both mechanical excellence and strategic blindness, proving that complexity could neither replace endurance nor secure victory. Allied veterans who had once faced its thunderous cannon now viewed it with contemplative distance, understanding that every technological marvel exacts a human price. The Tiger's rusting carcasses became memorials not to conquest, but to consequence, each rivet echoing with lessons forged in oil, smoke, and blood. By the dawn of the Cold War, nations revisiting their armored doctrines acknowledged the Tiger's enduring influence on post-war development. Yet its most profound contribution was philosophical, not mechanical. It reminded humanity that wars are not won by singular machines, but by balanced systems sustained through human resolve. The Tiger I remained forever trapped between admiration and tragedy, an indomitable creation undone by its own ambition. Beneath its shattered armor lingered a truth greater than any tactical report. Progress demands humility, and every engine of war carries the weight of those it sought to overcome.